Good morning. Things are running a little bit slowly today because the power had gone out, but it just went back on, so hopefully things will go all right. So the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting, but hang on, I got to turn off some stuff here. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Sorry, my computer rebooted and everything is coming back up. Okay, anyway, today we're going to review for the Chapter 9 test. I have some questions from students on WebAssign. So hopefully I can get that going. Sorry, everything's still running kind of slowly. Okay, let's see here. All right. We're gonna get there. This is 9.5. 6. Number 16. Okay, so here is the first question. This is from section 9.5, number 16. It says, solve the equation, enter your answers as a comma-separated list. And then it says, let's see here. Make sure I've got the right thing I'm sharing. Okay, let f of x equal the square root of 2x squared minus 17x for what value or values of x is f of x equal to 3. So we're going to substitute 3 in the place of f of x. So our equation is going to look like this. The square root of quantity 2x squared minus 17x equals 3. Okay. And welcome, Russ. Okay. Anyway, we're going to square both sides of the equation. And we're going to get 2x squared minus 17x equals 9. So this is a second degree equation. We want to set it equal to 0. So we'll subtract 9 from both sides of the equation. 2x squared minus 17x minus 9 equals 0. So this is going to factor 2x and x and a 9 and a 1. And let's see, this is going to be minus and plus. And I'm skipping the whole process of factoring. That's review. If you need review on that, let me know and I'll go through all of that. But anyway, so then we've got 2x plus 1 equals 0, x minus 9 equals 0. Well, if 2x plus 1 equals 0, so we get 2x equals negative 1, divide by 2, we get x equals negative 1/2. If x minus 9 equals 0, we add 9 to both sides and we get x equals 9. So our two answers are negative 1/2, comma, and 9. Any questions about that one? Okay, so now we're going to go to another person's questions. So give me a minute here. And let's see here. Okay. There. Chapter 9 review. Okay. So this is from the chapter 9 review. And this is number 12. Simplify the expression. Assume that the variable is unrestricted and use absolute value symbols when necessary. All right, we're taking the cube root of x to the 9th over 64. Because we're taking an odd root, we can get negative answers. So we aren't going to need absolute value bars on this problem no matter what, because we're not taking an even root. All right, we can separate this into the cube root of x to the 9th over the cube root of 64. The cube root of x to the 9th is x cubed. The cube root of 64 is 4. So the final answer, x cubed divided by 4. Any questions on that one? All right, that takes us to number 14, still from the chapter review. Simplify the expression. Assume that the variable is unrestricted and use absolute value symbols when necessary. We're to take the 7th root of the quantity x plus 9 to the 7th power. Again, we're taking an odd root, so we don't need to worry about absolute value symbols because we can get a negative answer. The 7th root of x plus 9 to the 7th is x plus 9. Number 17 coming up. It says the total surface area of a cube is related to its volume v by the function a of v equals 6 times the cube root of v squared. Find the surface area of a cube with a volume of 64 cubic inches. So a of 64 would be 6 times the cube root of 64 squared. Okay, well, let's see here. 64 squared. 64 squared is 4,096. Okay, I'm going to take the cube root of 4,096 on my calculator. And I get 16 times 6 is 96, and that would be square centimeters. Any questions on that one? Okay. We're going to take.
Can't hear you.
There we go. Sorry. What else can go wrong today? Okay. Is this Monday? No, apparently not. All right. So what I'm going to do now is share the WebAssign screen. Can you see number 19 on the screen there? Russ? Can you... Is WebAssign showing up on the screen?
It is, but you're coming in super choppy. It keeps freezing.
Okay, well, I'll do the best I can. It says graph the function f of x equals the cube root of x. Okay, so what I'm going to do, I'm going to go back to my whiteboard screen, and let's find some solutions to this equation. Since I'm taking the cube root of x, it would be nice if x was a perfect cube. So how about -8? Let's see, -1, 0, 1, and 8. When x is -8, f of -8 is the cube root of -8, which is -2. Is it coming in okay now? Yes? No? Russ, can you hear me okay now? Is it coming in all right now?
You just froze for probably 20 seconds.
Ah, okay, well, we'll keep pressing on ahead, I guess. All right, if x is -1, f of -1 equals the cube root of -1, which is -1. F of 0 equals the cube root of 0, which is 0. F of 1 is the cube root of 1, which is 1. And f of 8 is the cube root of 8, which is 2. So I've got these ordered pairs. So I need to figure out which of the graphs contains those ordered pairs. And tell you what, let's go ahead and do this. We'll pull this thing over here since everything else is going wrong anyway. Give me just a minute here. Things adjusted. All right, now you should be able to see WebAssign and my whiteboard as well at the same time. So we're looking at 4 possibilities for 19. -8, -2. Let's see, -8, -2. It's not that one. -8, no, it's not that one. -8, -2. It's got to be that one. So it has to be this graph over here is the only one that even fits just even the first point. And then -1, -1 is there, 0, 0, 1, 1, 8, 2. So it would be this graph. All right with that? Okay, we're going to go on to number 20. And 20 is the same thing. Let's see here. So number 20. Oh, I thought I chose the black pen. Let's see here. There we go. So number 20. Okay. Graph the function f of x equals negative the cube root of x plus 5. Well, that negative sign is outside of the cube root, and the plus 5 is outside of the cube root. So again, I'm still going to use x values that are cubes. So now f of -8 would be negative the cube root of -8 plus 5, which is negative times -2 plus 5, which is 2 plus 5, which is 7. Okay. F of -1 equals negative the cube root of -1 plus 5, which is negative, and the cube root of -1 is -1 plus 5. Negative is 1 plus 5, which is 6. F of 0 would be negative the cube root of 0 plus 5, which is -0 plus 5, which is 5. F of 1 is negative the cube root of 1 plus 5, which is -1 plus 5, or 4. F of 8 is negative the cube root of 8 plus 5, which is -2 plus 5, which is 3. Okay, let's see here. -8, 7, -8, 7, -8, 7. Yeah, and here again, even after finding just the first point, I can tell it has to be this one down here, but I wanted to finish up the calculations anyway. So -8, 7, -1, 6, 0, 5, 1, 4, 8, 3. So it's that graph. All right. Well, that concludes the questions that students emailed me with. So now let's go to you. Russ, do you have any questions to get ready for the test tomorrow?
No, you basically covered everything except for this one and the last one. Where did you get the -8 from to begin your table?
So this value right there.
Uh-huh.
Okay, so what I did was looking at the function, I'm taking the cube root of x. Okay, so ideally, I want values of x that are cubes. Now, I could pick numbers that aren't cubes, but then I'd have to go to my calculator and I'd get some decimal approximation. So I'm deliberately picking numbers that are cubes so that when I take the cube root of the cube, I get a nice number. So -8 is -2 cubed, -1 is -1 cubed, 0 is 0 cubed. In other words, I chose perfect cubes to make life easier. Does that make sense?
Yeah, I see.
Yeah. And again, same thing on, let's see, where did 19 go? 19, same thing there, because I was taking a cube root of x. All right. So again, anything else that you want to look at?
No, I think that's about it.
All righty. Well, I think I'm going to call it a day. It's been a day with all the things that have gone wrong. If students still have any questions, they can come back at 1:15 to my office hour, assuming the power's on. We'll see what happens. But anyway, take care. I'm going to go ahead and stop the recording.